All right. I kind of do an example of dropping a ball. We'll kind of look at that real quick. I mean, think about it. Think about something before we even do that. If I want to drive to New Orleans to visit my daughter, all right, it takes me about 3 hours to get from my house to her house. All right. For sake of easy in your head, suppose it's 210 miles from my house to where she lives in New Orleans. So how fast was I going? How long do you?
How long?
I mean, I'm sorry, what was the speed?
7 hours.
Now, she said 70 miles an hour. Does that mean I'm going 70 miles an hour the whole trip? No, what is that? That's an average. All right, now, without calculus, you can do average. With calculus, you can do instantaneous. All right, so what they're doing in this example on page 137 is they're moving from kind of average velocity, all right, to instantaneous velocity. So they remind you that way back in elementary school, you had a formula that says what? D equals R what? T. So if you want your rate, you take your distance and divide by your time. Okay? Now listen, they change it to, instead of putting D, they change it to delta S over delta T. Now delta S means position, like where are you physically at that point. All right, so here's the example that they use on page 137. It says this: a billiard ball is dropped from a height of 100 feet, and the ball's height, S at time T, is given by this function. All right, so they're giving you this function right here. Now, S is, it's 100, I guess. S is position. So what S is going to measure is where the object is in relation to the Earth's surface at any time T. All right. So they ask you to find the average velocity when T goes from like 1 second to 2 seconds. So over that second, they want to know what the average velocity was for that ball after they dropped. All right, so from 1 second all the way to the second second. Now, if I'm going to use this formula right here, I'm going to find the change in the position. So they kind of show you in your book what they're going to do. So basically, they're going to take the position at 2 seconds. Where's the ball after 2 seconds? They're going to find where was the ball after 1 second. So what are they going to do with those two positions to find how far the ball traveled, the distance? They're going to subtract it. And then they're going to do their change in time. So at the end, their time was 2 seconds. At the beginning, their time was what? 1 second. All right, you got your calculator. So go find me S at 2, and then go find me S at 1. I'll know what to plug in. All right, so when you sub in 2 squared is what, 4? Negative 16 times 4 is what, a negative 64 plus 100. What did you get for this position? S at 2 was what? 36. All right, what happened when you plugged in 1? What did you get? 84. And then, of course, 2 minus 1 is just 1. All right, you got the calculator. What's 36 minus 84? Negative 48. Now, they're doing it in probably feet per second. All right? Now, why would it come out to be negative?
The distance is
Because it's what?
decreasing.
It's velocity, it's not speed. All right? So do we understand that velocity is just speed with direction attached to it? So the ball is falling at 48 feet per second. Is everybody with me? But which way is it falling?
Yeah.
So if they ask for the velocity, if they ask for velocity, it's a negative number. If they ask for speed, it's the absolute value of that. Okay? So that doesn't mean the ball was going at 48 feet per second every millisecond. That means that was the what again? The average. Well, what if instead I squeezed it? What if I said I want from 1 to 1 1/10 seconds? So instead of giving you a second, I'm going to give you a tenth of a second. Go find me the average speed on that tenth of a second.
It's going real fast.
So the only difference now is I'm going to have a 1 1/10 right there. And then I'm going to have a 1 1/10 right here. All right, so what did you get when you subbed in that 1 1/10? What did y'all get when you squared 1 1/10 multiplied by negative 16 at 100?
80.64.
80.64. And then I'm still going to have that S at 1, so that's still getting to 84, wouldn't it? But instead of it being a 1, what's going to be down here? What's 1 1/10 minus 1 is just what? So what did you get for your average velocity this time? Negative what? 33?
0.6.
Now, is it going faster or slower average wise? It's going slower here, isn't it? Now think about why.
Gravity.
Gravity. When you drop that ball, what's it doing as it comes down? Speeding up. Now, what if I shrunk it from that to this? Is everybody with me? And I shrunk it down further. So what I really want to know is, I want to know exactly how fast this thing was going in exactly 1 second. So I don't want an average. I want instantaneous velocity. So look what's happening. What am I doing to this distance between these two? What am I doing every time? I'm what? Shrinking them. So what's the change in this denominator? What's this delta t approaching? 0. That sounds real familiar. Where denominator's approaching 0. What's that the definition of? The limit, as something's approaching 0, what's that going to be the definition of? Derivative. Velocity is just going to be the derivative of position. So in other words, if you were writing it out definition-wise, you know, you'd have the limit of f of t plus h minus f of t all over h is approaching what? 0. It's just what you did for your pop test. Only your variable's not x, your variable's what? T. But you know how to take a derivative. So look at the problem they give you on page 138 that we're going to start with, and I'm going to bump it up a little bit. Now, I'm always going to give you the position formula. Okay? So you're going to be given your position formula. So look what they say on example 11 on page 138. Here's what it says. At time t equals 0 seconds, a diver jumps from a platform diving board that's 32 feet above the water. The initial velocity of the diver is 16 feet per second. When does the diver hit the water, and what's the diver's velocity and impact? So here's what they're telling you. they're giving you a formula, so I would give you the same kind of formula. They give you this formula that says this. You've got a negative 16t squared plus 16t plus 32. Now, that's your position formula. So I will give you that. You don't have to come up with it. So I want to make sure we're clear about something. All right. Now, think about it. That will give you where the diver is in relation to the surface of the earth at any time. We'll talk about that in a minute, but in the domain. So I've got a diver on a board. He or she jumps. Now I want you to think about something. When you jump, when something's thrown, if you shoot something, if you jump, that object goes what? Up, 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 up. What happens for a fraction of a second when it reaches its highest point?
Velocity equals 0.
Velocity 0, because it stops. So if you want to know when did the diver, we'll put object, reach its highest point, you know the velocity must have been what? 0. All right, if you know position, how do we just say you find velocity when you know position? Take the derivative. All right, so what's the derivative of that? Negative 32t plus 16. Do we see where we got that? Okay, we don't touch numbers in front. So when you took the derivative of the t squared, the 2 came down. So you had 2t to the first. And then that 2 and that negative 16 is where we got the negative 32. And then the derivative of 16t, does everybody see why it's 16? Because what are derivatives of just single variables? We've already said they're what? They're 1. So 16 times 1 is 16. And then plus, what's the derivative of constant? 0. So if I want to answer this question, when did the diver reach his or her highest point? What am I going to do with this velocity formula? Set it equal to 0. Negative 32t plus 16 is 0. All right, so what's that get me? 16 is 32t. So what's t? Is t 2? Because I get that a lot. No, what's t? 1/2. It's not big divided by small. So 16 divided by 32, it took half a second. So if that diver jumps, half a second later, that diver's at the highest point. So I have a question. Question 2. What was that highest point? How far above the ground was the diver? Now, what does this formula do right here? It gives you position at any time. So what do I do? Well, I know it took a half a second, so I'm going to do what with that half a second? Plug it in. I'll plug in that half a second. So what was that maximum height? 36 feet. Now you got to pay attention to the question though. What if I said, so how high did the diver jump? Did he jump 36 feet? 4. Why? Because the diving board was 32 feet off the ground. All right, so we're just using common sense. Now, the diver goes up, 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 up. For a fraction of a second, we're stopped. Then we start back down. And here's what I want to know. it did, the diver hit the water. Now, the pool is on the Earth's surface. Is everybody with me? So the diver's coming down, 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 down. Now, before it answers the question, tell me the velocity is 0. So when the diver strikes the water, is his or her velocity 0? No, so that's not going to help me now. But I do know something that is 0. What's 0 when the diver hits the water? S is 0. Didn't I tell you S is measuring the positions of the diver in relation to the ground? So if the pool's on the ground, how far between the ground and the pool? What? Do you understand why S is 0? So all I've got to do now is I've got to set S equal to 0. Now, there's a difference between plugging in 0 and setting something equal to 0. So I've got a negative 16t squared plus 16t plus 32 equals 0. Now, most of these are not going to come out pretty, all right? And if you don't like big numbers, Pythagorean theorem, what's the first thing you should always do? All right, what can I factor out? Now, if I factor out at 16, that's going to make that a negative t squared. That's fine. But if you don't want a negative t squared, what should you factor out?
Negative 16.
So you want to factor negative 16 out because you get t squared, but you won't get plus t, you'll get what? Minus t and a what?
Minus 16.
Minus what?
2.
T. Now, in the book, they always like pretty numbers, but in the real world, there's not that. So, does this thing factor? Only way to get t squared is t and t, isn't it? So what are they going to factor into? T what?
Minus 2.
Minus 2 and plus 1. So does everybody understand that's saying that you're multiplying 3 numbers together? When you multiply the 3 numbers together, the answer is 0. So what do you know about one of those original 3 numbers? It was 0. So either a negative 16 is 0, or t minus 2 is 0, or t plus 1 is 0. Is a negative 16 0? No, so that's not going to work. So what's the solution in the middle one? T is going to have to be what?
2.
2, so we're doing seconds. What's the solution of the third one? T is going to have to be a what? Now, what's the problem here? What did you just say? That's a good math answer, but in this context, it what? It doesn't make any sense. You can't have a negative time. So apparently it took 2 seconds for the diver to come down. Now here's what I meant before. What if I wanted to know how fast the diver was going at 1.5 seconds? What would I do? What's the velocity of the diver at 1.5 seconds? What would I do? Okay, when you say put it, what's it? What am I putting 1.5 into? I asked you for velocity, so it's got to go into the what? The velocity formula. If I want the velocity after 1/3 of a second, that 1/3 is going to go in the velocity formula. What if I want to know the speed after 5 seconds? Can I plug a 5 in there? Yes or no?
You could
Is it
try.
valid? Why is it not valid? He's done. He's on the side of the pool. So when I say it's got to be in the domain, this thing started at t equals 0. When's it over? When t is what? 2. So those formulas are only going to be valid between t equals 0 to t equals what? 2. If you plug in, if you substitute a number outside of that, it's not valid. You're not going to get a correct mathematical answer for that situation. So it's got to be in your domain. Are we okay? All right, then you try this one for me. All right. Look on page, let's say 141. 141. All right, we've got a silver dollar dropped from the top of the building that's 1,362 feet tall. All right, I would give you the position formula.
101, where, 101.
Page 141, number 101. Okay, so there is your position formula. All right, I've got some questions I want you to answer. All right. I want you to find when the silver dollar hit the ground. And then I want to know what was the velocity and impact. All right, so find me when that silver dollar hit the ground, and then I want to know what was the velocity at impact.